For the last several months, I have been working on something new. I believe that my new open source project can help all of us make our code more beautiful and more efficient. The name of my project is Agile Data, although I'm open for a suggestion for a better name. Our application code is based on layers. The low-level code is responsible for things such as fetching or storing data. The mid-level code manipulates the data according to business rules. And the top-level code is responsible for presentation of data. Agile Data helps deal with the business and the persistence logic of your application. Apart from a few exceptions like Doctrine and Propel, the majority of MVC PHP frameworks today are focused on the presentation of your app, while giving you very basic tools for business logic building and database interaction. I have designed my framework so that you can use it inside your favorite MVC framework or application, adopt it into your workflows, test suites, API implementation, command line tools, or even cron jobs. And instead of just a lightweight ORM or query builder, Agile Data is a very powerful framework that can solve virtually any use case with incredible efficiency. My further presentation will focus around the following core features, which I will explain in just a moment. But to help you understand how Agile Toolkit works, we'll have to look at the specific scenario. Imagine that you're a developer working along with a team on building online accounting application. It will be used by third-party users who could register and then enter their own suppliers, clients, as well as their invoices and payments into your system. The object structure I have on the slide is really very clear. However, wait until you see the database storage. It all starts pretty nice with the first two tables, user and the system, which relate nicely to each other. However, as we look deeper inside the database schema, you start to see some differences. Whoever was designing this database, he decided that having two separate tables for client and supplier is inefficient. Instead, they will put them on the same table and I'm going to call them contact. Additionally, he figured that the user and the contact both have the contact information, which can probably be stored inside one same table, just to avoid duplication. The patterns like that are called data normalization, when you group the data inside the similar looked table. And it's just the extension of the do not repeat yourself principle. If you look inside the invoices and payments architecture, you will see yet another technique that is often used by the SQL engineers. It is called disjoint subtypes. And in here, invoice and payment both are presented by three tables. Whenever you need to select an invoice, you have to join it with the document table, and the same goes for the payment. So with ever-increasing complexity of our database schema, how can we map it under the very simple and very understandable entities? And this is exactly what Agile Data does for your business logic. It allows you to control the complex behaviors inside your database by using a simple models, just like this. Let's take a look at the presentation code. You might say, well, it does look like any other ORM, like Propel or Laravel's ORM. But what you have to understand is that entities like clients and invoices, they actually map into all these database patterns I was showing you, and it happens transparently. At this point, let me ask you a question. Should the rest of your developer teams and the rest of your application code be concerned about intricacies of your database schema? I'm pretty sure they shouldn't. And that's the beauty of Agile Data. It allows you to hide the complexity of the persistence, such as SQL in this case, behind a very simple API. This is how it looks like. This is how it looks to load a client, load a system, load a client, and then add a couple of invoices. Very simple and clean code. So to give you a summary, Agile Data implements a bidirectional mapping between your database schema and your business logic in a very new and intuitive way. It handles joins, both strong and weak, forward and reverse joins, and it can even import models as the joins. It handles fields. You can rename fields in a database without affecting your business logic. You can map types, map names, and you can define action-based hooks, such as before save, after save. Agile Data supports relations. You can traverse relations using has one or has many relations. It also supports contained data. It probably doesn't make sense for SQL, but if you're using API or NoSQL as your data source, which is entirely possible with Agile Data, some of them use hierarchical structures to to embed different types of records. And Agile Data supports that as well. Cross-database relations, as well as you have very powerful expression engines, which can be either database agnostic, or can be something like PHP callbacks, or can be something like a SQL expression, and you're entirely in control over all of that. At this point, I'm giving a demo, and then following up with the next section. My next section is about datasets and actions. And this is what fundamentally distinguishes Agile Data from the variety of so many other ORMs out there. So to start, let's look at one of our tables called contacts. And whoever designed SQL schema, he decided he wants to keep both clients and suppliers in this database, in this table. Also, you see that the records belonging to different systems are actually stored in here. When we write code like that, you'll see that there are some conditions applied, and our dataset is narrowed to only 2 records. If you or any other developer tries to load record outside of the dataset, he gets failure. That's a fail-safe security mechanism built into Agile Data to keep your data consistency. The other fundamental concept that innovated by Agile Data is called actions. Whenever you have dataset, you can execute an action and it will affect all the records in this dataset. So in this example, I'm executing an update action which will change field status to active. And the beauty of this is that instead of iterating through those actions and changing them one by one and then saving them back into the database, this action is executed inside SQL, because SQL does support multi-record updates, as well as many other NoSQL databases today. So in this scenario, there are 2 conditions using system ID and type. However, you can traverse from one dataset into another dataset. For this specific model, will contain only 2 records, which corresponds to our suppliers. And again, you can execute actions in here as well. Here I'm showing you another type of action, which is aggregate action. It executes the sum across our data set and will respond with the sum of all of our IDs. I did choose IDs because there are no other columns, so it does mean giving back 4. To summarize, the capabilities of data sets and actions, they are here for your application security, to prevent from accessing records outside of your dataset accidentally, and also to enforce that when you add new records, they are part of your dataset. Datasets are amazing for traversing relations because it costs you no extra queries. It allows you to perform deep traversal. Agile Data also features a pretty interesting extension system, so you can build new type of relations. Datasets also work for NoSQL databases. Things like sum, max, count, and so on will be emulated if your database engine doesn't support it. Whenever you have to cross from one database into another, Agile Data automatically figures it out and it executes the query, gets a list of IDs, and then use this list of IDs inside another database because that's the only way. However, if you are on the same database, then it will use expressions and will just substitute expressions. Performance. So when you use ORM, there are a number of performance issues that can slow down your system. If you think in terms of dataset and actions, you can avoid hitting any of those problems. Actions always make use of database features if they are available. And then whenever new database comes out, or maybe existing NoSQL database adds a new feature, their respective driver could be improved to support this feature and execute a couple of these actions on the server side. So think about aggregate framework inside MongoDB. It's just built for actions. The last and pretty fundamental feature of Agile Data is business model aggregation. And the reason why it is not a regular aggregation but a business model is because you build aggregate models on top of your existing models. And all the complexity, all the joins, all the expressions, it is all correctly embedded inside. You don't have to worry about any of that. So let's look how can we use aggregations. So in our schema we have clients, and client has invoices and payments. We can combine those using a union inside a separate model, which will be called client statement. And the client statement will contain records for both invoices and payments, showing you the history for a specific client. And it will behave just as a regular model, except that you won't be able to edit the records and send them back. And then finally, you can use a combination of the client model and the client statement model to create a new model called debtors. And this will show you all the clients who owe you money at this point. So you have to perform a join, you'll have to do some aggregation, and you have to do a condition saying that you're only interested in clients whose balance is below 0, and this is a list of clients you need to chase your money from. So aggregation and reports, they offer you an additional layer of how you can utilize your nicely defined models. So first thing you can do is create derived models. And while the source of regular model is typically a table inside your SQL database, for derived models, the source is another model. Model can import or aggregate fields from the source model. And then finally, you can query some specific fields, which means even if you define hundreds of expressions inside a model, you can only select specific ones, so you're not wasting CPU or bandwidth. And finally, derived models can be nested, so the source of a derived model could be another derived model. Union is a special type of derived model because it derives from multiple models, and it can combine them and it can figure out which fields to show and not to show. It handles joins, expression, and subselects transparently, and it does field mapping for you. Finally, there is also a good NoSQL support. You can do in-memory processing on aggregation, which is based around declarative logic and iterators. And you can define your own routines and make use of caching if you want. However, when it comes to performance, using derived models and unions are extremely efficient when it comes to SQL. It is all totally based on business models, so you're unlikely to make any mistakes, and it's much faster than stored procedures, both in terms of writing them, maintaining them, and execution. Aggregation is coming soon to Agile Data. The rest of the features are already available as a part of Agile Data beta version. So at this point, I'd like to ask you to give it a try. Agile Toolkit is pretty new and I do need to hear your feedback. Try it in your project. If you like it, share it with your friends, with social media. It is absolutely free. It has MIT license and you can use it inside your both personal and commercial projects. We also have a list of simple tasks if you want to get involved. You can just browse the list and maybe there is something you can actually help us with. And finally, please do subscribe and follow us for any news. And if you consider using Agile Data inside your commercial project, then my company is offering support, SLA support, as well as long-term version support. We can discuss additional custom features with you, including custom database drivers, as well as you get priority bug fixes.